Good day, everyone, and welcome to today's session on the quality of electrical balance of system, or BOS components, in ground-mounted solar systems. It's great to have so many of you here to discuss a topic that's essential to ensuring solar projects deliver on the promise of clean and reliable energy. Let's start with something that everybody might have experienced or knows somebody might have experienced. Imagine buying a house that looks fine on the surface but turns out to be a problem later on. Bad roofing, shoddy plumbing or sloppy wiring. Often these problems aren't visible up front, but the impact, fire or water damage, can be costly, far outweighing the cost of the original components that were used. In a way, BOS components are like that. They might seem small, almost insignificant in the broader scope of a project, but when they fail, the consequences can be major. In fact, nearly a third of significant performance losses or downtime in solar plants can be traced back to BOS issues. We're talking about connectors, cables, and inverters that, while they don't make up a large share of project cost, are absolutely critical for performance and safety. Loose connections, improper installations, corrosion, these aren't just technical details. They're risks that can affect the reliability of the entire system. So why is this becoming a bigger concern now? The solar industry is expanding at a remarkable pace, and with that growth, old problems come back to the fore. We're seeing growing pains of an industry that's transitioning towards mainstream and system relevance. And BOS components are just one of these areas where the challenges are most evident. A recent report by Heliovolta reviewed over 100,000 solar installations in the US and found that 11% of these installations faced critical safety and reliability issues. Among the PV plants that were reviewed, almost none had a report on quality assurance or quality control. But instead, 83% of these installations, of these inspected sites, showed at least some issues that were related to cables and connectors. Let's put that in perspective. The cost of BOS components typically makes up around 6% of a ground-mount solar project. Individually, these parts might account for less than 1% of the capex. But their role in ensuring their price tag and the project's performance, safety and bankability is far from proportional, their price tag. It's a classic case of small things making a big difference, especially when they go wrong. To help us explore this topic, I'm joined by a panel of experts who will share their unique perspectives. From manufacturing side, we have Gary Oren, Senior Vice President and General Manager International at Scholz, who will walk us through the design and quality control processes for BOS components which they produce. Thomas Sauer is the CEO of Exergy, and he will give us insights into the kinds of quality issues his team observes out in the field. And Terje Mela, Senior Vice President, Engineering and Technology at SCATEC, will explain how EPCs tackle BOS quality during planning, installation, and operational phases. And Nathalie Grün from Recap will share how investors manage technical risk before and after solar assets are acquired. And later, in this session, we'll broaden the conversation to explore how maintenance strategies and emerging technologies and David Moser, a researcher from Eureka Campus, and Brad Barber, a head of operations and management from Belectric UK, will guide us through how AI and robotics are being used to test and improve the durability of BOS components. Today's discussion isn't just about the challenges, it's about understanding what's at stake. It's finding solutions to ensure solar projects remain not just clean and affordable, but also bankable and reliable. So let's dive in. But before all of that, it's now my pleasure to introduce Christian Dürschner to you. He is a distinguished expert witness for PV installations and recognized by esteemed organizations such as the German Society for Solar Energy, DGS or DGS. With his deep expertise and years of experience, Christian has been at the forefront of assessing and ensuring quality of solar installations. In today's presentation, Christian will take us through a real-world case study where issues with cables and connectors led to significant complications. We're in for a compelling look at how small oversights can escalate into major problems, as well as valuable lessons learned to help mitigate such risk. Welcome, Christian. Welcome to the program.
Yes, hello from Germany. Hello from Erlangen in Germany. My presentation will show you a very small part of the PV system, the connectors, the cabling, but a very crucial part, and I will tell you what can go wrong when it's not made properly. The thing is that the connectors are very often in the system. Every module has 2 connectors, but the connection between modules is not the problem. The problem is the connection between the end of the string and the string wiring, and also on the other side the string wiring to the inverter. Because there the installer has to make his own crimping with the right connector, and what is the right connector we will see over there. The thing is that we have a kind of market standard, the MC4 Stäubli connector, but there are no compatible connectors. They are named compatible, but they are not compatible. So choose the right connector, never mind the company, but think that you are not allowed to connect different connectors. No female or male connectors from different countries, from different companies, should be connected. The second thing is that our DC cabling is made for using on the roofs, but in the ground field installations you have sometimes to put it into the ground, and the question is this tested for that? Is it specified for that? And I can tell you that the original specification from the TÜV, also the norm, the technical standard from 2015 is not looking on the waterproofness, is not looking if the cable can be buried in the ground. So these are special things to have which must be tested if it's the thing to put the cabling in the ground. And when you have a perfect PV system but wrong cables or bad connectors, then you have an interruption in your string, and this may cause a temporary or permanent reduction of the yield, and you are losing a lot of money. There are several investigations. Here is one of the failure mode influence analysis of PV module failures. You see a lot of failures, but the thing is 3 times here, it's the thing that you have issues with the connectors, with the cabling, and you are losing really a lot of money if you are going wrong here in this way. Another slide shows this also. I've highlighted here both things, damages on the burned connections, damages on wrong cabling are here really the main issue. If you look at the discussion about compatibility, then you can go back to the year 2012, and it's still valid today, that Stäubli says there are no compatible connectors, and they they are not intended to authorize this compatibility in the future. If you look at the manufacturer installation instructions, there's some similar. This is just from one, but you can find it on other installations also. Please use identical connectors from the same manufacturer and model to connect, here in this case, optimizers and modules. But if you look at other installation manuals, it's always the information there. What can go wrong? Wrong can go that the connection in the connector is bad, and the left slide, the left picture shows you everything is fine, just a little warming. The right picture shows, oh, it's not so good. And what can go really wrong is when you have here at least a starting condition, slightly warming about 10 Kelvin or 20 Kelvin for the wrong connection, but it will increase up to 100 degrees Celsius. At least it might burn. I have brought you some pictures for that to show that. Another thing is that sometimes I was shown certificates about compatibility, but read carefully what's written in these reports. They always tell you it's just for the 8 examples were tested that this is compatible, but it's not an issue to say that the production complete will be compatible. It's important to have this because the 3DE BOS-712 tells us it is crucial to have connectors, female and male, from the same manufacturer, from the same product line, that it's working. You can download this here. I have integrated the link. And that's what's going wrong. You see here different manufacturers, female from one, male from another, and then it goes wrong. It shows corrosion. Also on the next thing, corrosion. The third, corrosion also inside, so it shows it's not very close, so the humidity or water can pour in and make our connection better and worse. We see it here again, and this leads at least to the fire. It's burning, and you see the connector is destroyed, but also the cabling nearby is also destroyed. So it's a small part, but a great issue if it's not working. Also, if you have perfect systems, no worry about the name of the inverter manufacturer, but he changed for some weeks or months ago the connectors at this inverter. And he gave also information to the installers, but the installer hasn't read it. So it came to the fact that on the one hand here were original Stäubli and Zephyr connectors. The inverter has amphenol Helios Hal4, and I went to this PV system and they had to change about 600 of these connectors. Wasted money, because if they had read it before, it would be very easy. Here's the detail picture of the Stäubli. Here's the detail of the amphenol Helios. And you see it here, it's written with every inverter, please, installer, note, we have changed our connectors. Please use the connectors we give you with the inverter and don't use other one. So it's very easy to avoid these failures, but they often happen and we should be aware of. Another thing is it's not burning only the inverter, sorry, not the inverter, it's not only burning the connector, but also the cabling. You see the right side, and the third picture shows it best. Here is just 1 meter cabling missing, because the cabling always burned, then the cabling was lost, no connection there. Please. Reason was the cabling was brought into the ground. It was not made for that. The datasheet told us that it was for ground bearing, but in fact it was not. So afterwards they changed also their datasheet, and the thing is we had at least about 12,000 euros damage in this PV system, but just was a megawatt system. Okay, I think that was, my conclusion. Quality is important. Quality is not a question mark. It's an Ausrufezeichen. The bitterness of poor quality remains long after the sweetness of a low price is forgotten. So it's not always the price, as we have discussed it in the morning. Of course, price must go down, but please always remember quality is the issue to have a long-lasting PV system for 20, 30 or even 40 years. Thank you.
Well, thank you, Christian Dürschner, for sharing your insights and expertise with us today. Your case study has highlighted the critical importance of quality control in cables and connectors, and it provided a clearer picture of the real-world impacts that can arise as these issues are overlooked. Understanding the potential costs and complications during the operational phase will lead us to the next part of our debate. Thank you once again for bringing this to us. We heard our expert witness, Christian Dürschner, about what could go wrong when EBOS components are of poor quality or not enough attention is placed on diligent work. It's now time to call our panel of experts, and we're honored to present a lineup of panelists who will bring a wealth of knowledge and different perspectives from the industry to today's discussion. First, we have Gary Uren. He's the Senior Vice President and General Manager International at Scholz, a global bigweight in manufacturing electrical balance of system components. And from SCATEC, we have Terje Mela from Engineering and Technology, who will walk us through how an EPC company can implement rigorous quality measures from the initial planning stages through installation and to the operational lifecycle of a project. And rounding out our panel is Thomas Sauer, the CEO of Exergy, a technical risk assessment company. Thomas will delve into how investors and asset managers can leverage comprehensive technical reviews and risk ratings to make informed decisions before acquiring assets and thereby enhancing investment security and asset longevity. And representing the side of finance and investment, I'm honored to welcome Nathalie Grün, a senior investment manager at Recap, an M&A advisor and asset manager for renewable energy, battery and charging infrastructure projects. She will discuss what role quality assurance and quality control play before acquiring a solar asset. Thank you all for being on today.
You're welcome.
Thomas, you reviewed many PV power plants that were subject to insurance claims. How common are these issues that Christian Dürschner experienced in the site he reviewed?
Yeah, thank you very much for that introduction. Yeah, I mean, we've analyzed about 3,600 or actually even more insurance claim cases, but moreover also power plants that we have reviewed or assessed, some of which were brand new and some of which were already a couple of years in service. And I can certainly confirm that there is a problem in the field that also includes, let me say, bad connectors, bad cabling, but naturally also module quality and so on. I have a small slide that I can show you. I don't know whether the backstage can kick that in. Page 2, please. Or the next page, basically. Yeah, there you go. So what we see here is basically the distribution of the damaged components as a function of service life. So on the x-axis, you see the service life in the year of operation at which the insurance claim case was filed. And on the y-axis, you can see the number of claims for a certain component. And you can see that throughout years 1 through 13, modules and inverters are actually leading, generally speaking. But it is quite interesting to see the mid-blue bar or part of the bar that is representing cabling, and cabling includes also connectors, which is quite a significant number in insurance claim cases. And so when we get to sites, I can absolutely support the statements from before, that it is an absolute must to look for good connection, because good connection results in lower resistance actually, and lower resistance leads to low temperature, and low temperature leads to longevity. Okay. On the flip side, if you have high resistance, you have high temperatures, and then you can get temperature levels at which the system can start burning.
Okay. Nathalie, from an investment perspective, how do you assess the financial risk that are posed by these technical issues in BOS-components?
Thank you. So we do our best to first reduce and then mitigate the risks. So that means when we acquire a PV project or when we build them, we carry out a technical due diligence first. And this with the help of technical advisors to make sure that there are no red flags or that we can maybe improve some of the specs. And that means that if, for example, the contracts are not yet finally negotiated, we include aspects like specifications of connectors, maybe specific brands or types, or at least that these must be matching, like we have been explained before, and also that they need to be installed according to manufacturer requirements. But this is only the first step. Then also, of course, we have our technical advisors going on site during the construction and also when the construction is complete to confirm that these components have been installed the way they should be installed, according to the contracts as well. And then later on, during the O&M period, during the operations of the site, we sometimes also carry out electrothermography to make sure that also in the long term, these components are working the way they should. And last but not least, to mitigate the risks, we also have insurances for all the things that we cannot reduce.
Okay. Okay, we're hearing there are ways to test the technical diligence of the work. But let's hear from an EPC, Terje. You have a lot of experience handling various components. Are there certain trends that you're observing in terms of reliability of these EBOS components? Are there certain designs that are more prone to issues?
Well, thank you for the introduction. And well, since I joined the industry, the solar industry, the project has grown quite significantly in size. I mean, back when I joined, 50 megawatt was considered a huge project. Now we are starting the construction of a 1.1 gigawatt project. That means we have like hundreds of thousands of cable connections from medium voltage, low voltage, AC, DC, signal cables, fiber optics, etc., all of which are potentially causes of failures. And on top of that, we have the inverters, combiner boxes, and fuses, lighting protection as part of the EBOS as well. So it goes without saying that we do experience cable failures, especially during commissioning and the early operation of the project. But what we see is that the reliability issues are more related to workmanship during the installation rather than the design. I'm speaking on behalf of my company, at least. This goes on specifically things like cable management, cable pulling, laying the cable in trenches, doing the cable joints and the connections. And as we operate in many different countries, we are in the Middle East, Africa, Latin America, and Asia. We see large variations in the competence and capabilities of the contractors that are doing the work. And the attention to quality of the installation is absolutely critical, and it can be easy things such as using the right tools that has been talked about earlier, and to wearing gloves during when you are actually doing the terminations. And the way we are mitigating this is having a very strong focus on quality during the construction phase. For example, by doing proper training of the contractors and 100% witnessing of the work performed from the beginning to ensure that the procedures are being followed.
Okay.
Now, one last thing. On the design side of things, this was the workmanship. On the design side of things, I can highlight maybe two areas that we have experienced issues historically. First is the combiner boxes that we consider as a weak point. We have the connections of the strings, obviously, but also the fuses and the fuse holders that are can easily cause hotspots. Now we see that with string inverters bringing a clear advantage in this regard. And the second thing is about wired communication, such as RS-484, which is also a problem, has caused a lot of problems. Now the trend is more on going wireless or using power line communication, which reduces the problem significantly.
Okay. Gary, I want to play this ball to you. I mean, we just heard from the representative, Terje, from an EPC, that workmanship and easy to handle designs are an issue. You're in the business of designing and producing EBOS components. What are the challenges?
Yeah, look, first of all, thanks very much for having us to this call and for having this conversation. I mean, I think it's extremely important. I think we're hearing from all of the speakers that there is a considerable vulnerability with a lot of the sites that are developed based around the on-site manufacturing or on-site installation, if you like, of the EBOS system. We take a very strong view on EBOS. We consider it to be not a thing that connects other important parts, but really the most important part. In other words, if you think about it, what we're installing in fields around the world is effectively a system, and the connectivity that goes between those parts is EBOS, and that's part of that solution. Just touching on the points of connection. I mean, 1 gigawatt from our analysis is something like 1 million connections that are done on a job site, and I think it's not hard to imagine that being able to do that many connections in adverse conditions frequently is an obvious risk to installations. I think the other thing I'd just like to add to that discussion is just the lack often of a clear design when these installations are done ad hoc on a job site. I mean, clearly what Scholz does is a pre-engineered and prefabricated solution that's tested in factory. So when we're shipping something out, we know it works before it leaves our factory. We've debugged the solution, and we know that when it gets there, it's going to work. We know that our connections are IP68 or better. So we know that irrespective of the conditions that are on the site, whether it's water, snow, rain, mud, we know that we're going to have good, safe connections that are consistently there.
All right. I want to play this to Thomas because Gary, quick note to our producers. My earpiece just died. Maybe we can do something about that. I'm having trouble understanding our panelists from now on, but I do understand you a little bit still. Thomas, do you see innovations that were just talked about by Gary addressing some of the most common failure points that you identified in your data review, and are there areas where the industry is still falling short in preventing recurring issues?
Yeah, thank you for that question. First, I would like to also point to Terry's point with growth and size. 50 megawatts those days, and now almost gigawatt scale. This generally also results in quality risks, let me say. But to Terry's statements, I think it's the approach that Scholz is taking is really a very good one, because it takes out a lot of the risk that you encounter when you go on site. Yeah, if you think of combiner boxes that are all connected on the site, that's always a bigger risk for failure and of pretty hazardous failures eventually, compared to if you have a prefabricated complete tool set of cables that are basically already prefabricated merging together. That provides a really good a good segue to reduce the risk for these types of failures. And we do see that in the field, that the level of quality of people that are actually installing in the field is extremely important. And that's also to Terry's point. It's absolutely crucial that you have well-trained people, and that you actually stay on top of things constantly during the construction phase, where a lot of the failure modes are actually preset. Let's not forget, around 75-80% of the overall investment is or life cycle cost actually is happening in the inception phase, and it's extremely important from the manufacturing of components all the way through commissioning that you do get the job done right. And this is the biggest difference, I guess, to any other manufacturer or electricity production unit out there. Or technology that this is the case, yeah, and so prefabrication is really a good means in that sense.
Terry, as an EPC company, do you also evaluate suppliers how they can ensure that their components require quality or meet quality requirements, or how easy they are to handle? Is there a standardized process for this in your organization?
Yeah, we have developed our own process for this, and it varies from type of components, obviously. But in general, we have a three-step process. The first one being for the key components, we do a proper, and for the EBOS, that will mean typically the inverters. We do a quite thorough technical due diligence process, which even might involve lab testing and factory visit. So we have a selection of what we considered approved vendors for our projects. And then the second step is in the actual project. When we are selecting our technology and our vendors, we do what we call a tier report, tender evaluation assessment report, where we look at the vendors in many dimensions: commercial, technical, sustainability, but quality as well, and the risk and delivery capability. And then when we are coming to the actual delivery phase of the product, we often have representatives on the manufacturing location to monitor quality during production and the outgoing quality by spot checks. So, of course, we are not able to do this on all our procurement items, so we focus on the most important ones based on the lessons learned from previous projects.
Okay. Similar question to Nathalie. Do you also have standardized processes or processes in place how you can evaluate whether innovations are reducing or improving bankability and reducing technical risk of a project?
So we ourselves, as mentioned before, usually use or work together with technical advisors who have the time and also the knowledge to dive deep into the data rooms and the informations we are given. So they would usually raise these topics either for things that don't work out that well, or to say thumbs up to new solutions or not. And so whether it's banks or us, if the technical advisors do approve the idea and there's enough proof that these solutions work, then there is for us no objection. And best, of course, is to see these things already working on other sites or having already maybe also scientific proof. This helps a lot. But of course, like in the case mentioned before, with the cabling already pre-assembled, I can't imagine anyone objecting to that, because this is quite obvious that this is very, very helpful to reduce risks for the cable installation on site.
Okay, Gary, I see a lot of improvement for your solution from our panel. A question is also, I mean, there are projects that maybe also Nathalie is acquiring that are already built, and a question would be, is it possible to later upgrade to this solution that you're offering?
Yeah, sure. Of course it is. In fact, I was thinking about the sort of, if you like, the industry trends that we're seeing at the moment, and one of those industry trends that we're seeing is, in fact, us being asked to come back to sites that have been up and running for a few years to repower them using our prefabricated solution. I mean, we, regrettably, and no one wants to see anyone have problems with any site, especially when it's something as important as renewable energy. But the fact of the matter is, we do see at the back end people that have perhaps elected to do an on-site build of a system. They're coming back and saying, "Hey, could you guys come in and fix our system for us?" So it's a real issue and a real problem.
Okay. Okay, a real issue and a real problem is also, we heard from many stakeholders in the industry that there are no standards. We heard it initially, there's the MC4 connector that's by one company, and it's actually a product, it's not a standard. We hear MC4 compatible, which is, you shouldn't apparently use any MC4 compatible plug into another company's counterpart. So where are we in the industry with in terms of standards? Terje, do you know of something, or would that help you in your processes to guide your workers out in the field?
Yeah, definitely. That will help a lot. And we are very cautious about, in our design, not to use connectors from different vendors. But again, going back to what I mentioned earlier about the contractors that we use on site, we don't necessarily have control of everything that they do in these big projects. So again, training and monitoring of the work on site is critical. One of the most critical things, I think, in terms of reliability and quality of the plant.
Okay. Gary, also from you, I want to know from you what is the industry working on? Is there some movement in terms of standards? Are there some standards that can be followed already?
Yeah. So I think the gap sits, and it's been touched on earlier. The gap sits on the fact that at the moment, if you're doing it on a job, if you're building a system on a job site, you're effectively have standards that relate to the individual components, not to the complete system. In the US, that's a little bit different. There is a UL standard that is more systems oriented. In other words, it takes into account the completely integrated solution, and I think that's a direction I think that the industry should be looking at is how to capture the final solution rather than the parts. In other words, if you were to buy a car, for example, you wouldn't want it'd be nice to know that all of the individual components that go into the car are all built to some standard or another, but you probably would hope that there was some standard that covered the putting that car together rather than just relying on the individual discrete components that are tested.
All right, let's play that question to our investment manager. As we look for solutions to enhance solar project bankability, Nathalie, do you think the role of quality assurance processes during the project acquisition could be met to some way by stricter industry-wide standards? Could they improve investor confidence?
Certainly. So I have the feeling, if I compare to what was happening 10 years ago, already standards have helped to reduce things happening on site a lot. And I'm sure that more and better industry standards would have a positive impact on reducing risks. I mean, the aviating industry is a very good example for this. And especially for smaller projects that might not have a budget for quality assurance at all, better standards would certainly help. But also, like we heard, like the huge projects where there's potentially millions of connections. There also would be very helpful. And also what has been mentioned by the other speakers, the fact that it's not only the components themselves, but it's certainly the installation that happens on site that is crucial, makes that the quality assurance, the processes, the technical due diligence, the on-site visits are very important. But of course, the more standards are out there, the easier it's to be checked for these standards, for them to be fulfilled. And also then in the long term, we have less incidents on site and the technical advisors can then focus on other things. So yes, I'm absolutely for more and also improved standards that describe things in detail.
Okay, something to work on for the industry. Let's leave on a productive note, and I want to ask this question to all of you stakeholders in this industry. What steps can you take collectively to reduce the risks and improve the bankability of solar projects? Maybe Thomas, start you.
Yep, thank you very much. Maybe back to the point of standards. There's 200 that relate to PV, and I think what is really missing is actually an internationally harmonized and accepted procedure that is defined to assess the compliance to these standards. As actually all of you guys said, Nathalie, Terry, and Gary, it is really to put the bits and pieces together. And what we have been working on, as you may know, I'm heading the PV sector working group at IECRE. We are trying to push for a system-wide rating system, and I think that could enhance bankability, because then this could be a good precursor for establishing a holistic approach to the whole thing. Look at the individual components, but also look at the assembly, which is extremely important in the PV sector. And so I would hope that maybe we can get more participation from the sector and also from the investors, because it's the investors who are hurt first, especially the equity investors, if things go belly up. And so that's my pledge. And the other one that I have is also in terms of confidence in the public, is that the PV sector is in the risk mode of losing confidence overall in the public domain. And if we continue to have not sufficient standards, then the PV sector might be prone to a lot of ammunition that we give to all those who are the naysayers, right? Yeah.
All right, Terje, let's hear from you. Are there any best practices that can be applied to already to improve bankability?
Yeah, for sure. I mean, first of all, there's a lot of positive developments in the industry, and in Scatec we have built now more than close to 6 gigawatt of solar projects. So we have a large knowledge base from many projects in more than 15 countries. So we have our developed design and construction guidelines that we continuously update. So I think this is one way that Scatec, as a global independent power producer, can contribute to the bankability of solar projects in general.
All right. And Gary, what do you think? What can be done already to improve bankability?
Yeah, I mean, look, I'd probably, not surprisingly, I'd probably say use shoals. But, look, I just want to add a different complexion to this as well. I mean, the other thing that's happening that we need to be aware of is that the voltages that these systems are generating are constantly increasing. I mean, starting sort of around, 600 volts a few years ago, and, in the US, everyone's talking about 2,000 volts, and I think in Europe they're talking 3,000 volts. So the issues that we're talking about as problems today get exacerbated when you start increasing the voltage. I mean, it's not hard to imagine if you've got a bad connection or a marginal connection on an installation and it's 600 volts, it's going to be considerably worse when the voltage gets higher. So I think I really like the idea of a harmonized standard, an IEC standard, that addresses that part, which is the installation and best practice design. I think is something that should be included in that at the end of the day. I think there's just a couple of thoughts there, but I think that I fully support more standards.
Yeah. All right, thank you. And Nathalie, you have the honor of having the closing remark to that question.
Thanks a lot. What we think, or what we'd like to do as investors is maintaining a very trustful and long-term relationships with our business partners. We have several EPCs with whom we regularly do projects together. We know how they work, and we realize that in the long term, this really pays out in terms of quality and good projects. So we see this as a big factor to reduce risks.
All right. Thank you very much to our panel for joining here today, for sharing your time, your knowledge. Also, special thanks to you, Gary. I know you're located in the West Coast, US, and it's very late at the night for you. Thank you. Special thanks for you to coming here on the show today and bringing your contribution to shed light on the critical steps needed to ensure quality, reliability across the solar industry. From manufacturing to installation practices and investment strategies and international standards, we've heard what can be done to understand the intertwined efforts that are required to maintain high-performing solar projects. Thank you for sharing your time and knowledge here with us today. As we move from discussing installation component quality to the critical topic of maintaining the value and reliability of solar assets, it's essential to highlight how good operational practices also play a key role. Operating and maintaining ground-mounted solar plants might seem straightforward, and panels, wires, sunshine, right? But those of you in the field know it's anything but. The system faces a range of issues that demand constant attention. For one, there's soiling. It's a relentless challenge. Dust, dirt can accumulate on the panels, and particularly in southern Europe's more arid regions. Then there are equipment failures, especially with inverters and trackers. As we just learned, there's also cables and connectors that are an issue. Panel issues are another constant headache. Microcracks, discoloration, and hotspots can all silently erode efficiency. And while these problems might start small, they can quickly compound into larger, costly repairs. Let's not forget the electrical problems like loose and damaged wiring, improper grounding, or frayed conduits, which can lead to safety risks and system inefficiencies. Add in vegetation management, overgrown plants blocking sunlight, or even damaging equipment, and environmental factors like water drainage affecting mounting structures, and the scope of the O&M challenges become clear. The big question is, can technology help? Can AI, robotics, and drones provide better solutions to these challenges? The promises are there. These tools offer the ability to monitor vast solar fields, detect issues early, and even automate maintenance tasks. What's the reality? How far have we come? Where's there still room for some improvement? To guide this conversation, I'm joined by David Moser, a researcher from the EURAC in an Italian research institute in the city of Bolzano. David is deeply involved in studying how AI and robotics can improve operation and maintenance for ground-mount solar systems, and his work focuses on leveraging technology to detect and address quality issues such as bad connectors and more efficiently ensuring long-term asset performance. And we're also joined by Brad Baver. He's the head of operations from Belectric UK, who brings hand-on experience to our discussion. Brad has already implemented robotics in solar fields in the UK and will share practical insights, how these tools contribute to more effective maintenance and asset management. All right, but the first question goes to David. We've heard from our speakers in the previous panel how important solid engineering and installation practices and component procurement are. David, you have a rather good overview over the occurrence of failures in solar plants. How common is the issue and with various components in the field?
Hi, first of all, thanks for having me and for the great discussion you've been having so far. Through the past 10 years, we have been collecting experiences from the field in terms of looking at maintenance tickets or direct experience from reliability experts. What is interesting to see, just to give you a few numbers, is that we started by collecting experiences with around 2,500 maintenance tickets collected by reliability experts. And in that specific case, it was the issue with EBOS, so interconnectors and cablings were quite prominent, with around 30% of the tickets involved. Those are components. Then, because we wanted the statistics to become more relevant, we have teamed up with several OEM operators. So they have given us around 250,000 tickets to look at. So a lot of work. And of course, the final results were biased by what is written in the ticket. So no more reliability expert, but OEM operators, let's say, in the field. And then the statistics for interconnectors and cabling went down to a few point percentage. So this is the message I want to give here is the statistics, the number that we also heard before. It strongly depends on who is sampling. At the same time, the clear message is that indeed, quality at cabling and interconnectors level is important. If we try to convert these numbers into an economic impact, for example, we develop a metric called cost priority number. For interconnectors and cabling, you could probably have an impact of 3, 4, up to 5 euros per kilowatt peak per year, which is a very high number if the failures get undetected.
Okay. Brad, is this also what you're seeing in the field?
Yeah, hi. Yeah, thanks for having me as well. Yes, very similar issues. Cable connectors and PV modules are very often the problem. Probably still one of the biggest problems is actually finding the faults themselves. Just listening to experts earlier, it's quite clear that we spend a lot of time trying to find these faults. We have a portfolio that's quickly approaching 1 gigawatt here at Belectric, and that's in the UK, and this needs to move faster. Can't really afford to spend weeks finding reasons for these downtimes on our assets, and new technologies such as AI and robotics are there to help us achieve that.
Okay, so when I'm hearing that you're using AI in your and robotics in your O&M, I'm thinking of a fully autonomous system. There might be somewhere a robot that's asleep in your solar field, and it wakes up when the monitoring system shows underperformance, and the robot goes there and does its checks and automatically analyzes the data of its inspection and maybe tickets a human fixer if necessary. Is this what you're doing, or is it still sci-fi?
I mean, it's maybe still a little bit sci-fi, but it's not too far off. The robotics can definitely help and save us the time from using skilled labour and sending engineers directly out to the field. And it's still early days. We're still doing standard checks and visual inspections. But what it does is allows skilled staff to have more time for the more demanding electrical tasks at hand.
Okay. David, you're working in the field of AI and leveraging that to improve robotics. Why is my vision still a bit sci-fi?
Well, do you know what is funny? I think we have proof of concepts, and also Brett is working on it. How we can really go towards autonomous workflows and OEM pipelines. But the issue is not this sci-fi part. The issue is the easy part, which is what should come before that. And instead is where we really have to focus our effort at the moment, which is, for example, interoperability between digital platforms, digitalization of the information, making sure that we don't lose information from one step of the other, using common nomenclature. I mentioned all the tickets before, and it's clear to us that we need to improve the quality of the information that we record in the maintenance logging. So yeah, it sounds like sci-fi, but we are actually the hurdles, the blocking, the limiting steps is what seems to be the easy part.
Okay, but you are working on the hard part. I know. What are you doing exactly?
So we recently started a EU-funded project called Supernova, where we teamed up with several partners in really exploring the automation of operation and maintenance pipelines. So exactly the scenarios that you have described before. So we are building a multi-AI agents architecture that we demonstrated that and presented in a few events, how these AI agents are talking to each other, and they are taking over the role covered by humans at the moment in the detection room, in the inspection phase by using drones and robots, and in the suggestion for the resolution of the issues.
Okay. So you're developing a new solution. Brett, you're using already a solution. Is that in-house developed, or are you going for some market-ready solutions?
It's kind of a bit of both. We're using some of the larger and better known kind of off-the-shelf products. But at the same time, we're trying to develop our own in-house system to take that data and turn it into something usable for Belectric.
Okay, developing this doesn't sound very cheap, actually. I mean, Elon Musk is building AI centers that cost billions, I suppose. What's the advantage? Where do you see the big monetary advantage to your organization?
I think it's a wider question. I mean, our primary goal here is probably to deliver the best possible service to our customers while adding value and being that forward-thinking service provider. Leveraging innovation, we aim to free up time really for engineers and the field technician, enabling to focus more on AC/DC field work and resolving the issues that AI robotics simply can't do at this stage. This is about reducing the burden of time and repetitive tasks, and we believe that a hybrid system integrated with future technologies will allow us to enhance an overall service quality, expand our portfolio, and increase our megawatts managed by the engineers, driving more efficiencies and probably just excellence across the board.
Is it also a motivation for some skilled labor that is at hand? I mean, we always hear that there's a lack of skilled labor that are available for such tasks, and I suppose that robotics can help with that.
Yeah, I mean, it's definitely a challenge, and I think that goes on to, as we get more and more megawatts and gigawatts, we can't just keep throwing engineers and people at it. We've got to look at how we can resolve these tasks in a better manner, and it's definitely about that. So there is a slight cost reduction in having autonomous robots and software that don't need breaks and can continue and analyze data faster than we can as humans. And as you say, there is a technical shortage, and we can address that with training, but we're always having the runaway of megawatts within the UK, where we're never going to keep up with the market with just allowing people to do these tasks.
Yeah. David, when you're working with such large data sets, evaluating all the faults, Do you see some statistics on certain designs? Can your work actually help the producers of EBOS components to come up with better designs because you see the weak spots, or the AI can then see the weak spots in certain designs?
Well, I would say that certainly the methodology would allow for it. Again, the type of information and insights that you can get out, it depends on the quality. If you have for example, in our database, we go from residential, so maintenance tickets for residential systems up to large utility scales. If you have a certain granularity and a combination of components, you could definitely derive the best, let's say, combinations depending on PV plant design, on climates, and so on. Again, quality of information is key, not just the quality of the components themselves.
Okay. I would imagine, Brett, that EPCs have catalogs of these types of informations at hand to know that in certain areas you're supposed to use this combination of various components, but these are built from own experience. Is that right?
Yeah, it's predominantly own experience, and I think there's an important part from EPC to O&M is that the quicker and faster we capture data at the build phase, the better we can understand and manage the sites in its operational phase. So I think they do have to work hand in hand to make that work. So I think the sooner we can get drones to track data, modules, cables, and combiner boxes, we can take that data and then run trend analysis across the operation as well. So I think it has to be a hand-in-hand solution.
All right. Well, the process is known, and AI can help us leverage and improve this process and eventually end up with a higher, more reliable and safer solar system. Thank you so much, David Moser and Brett Barber, for sharing your expertise and knowledge with us today. Your insights into the potential and current applications in AI and robotics in solar operations and maintenance have provided a clear look at how technology can transform our practices and enhance reliability. As this session ends, I want to reflect on the key insights we gained today. We started with an in-depth look at the quality of installation practices and the critical role of EBOS components can play in ensuring reliability of solar systems. We then transitioned to how robust operational and maintenance strategies enhanced by investments in AI and robotics are vital for maintaining the value of long-term performance of these assets. Our expert panelists have shared their valuable knowledge and experiences from examining technical audits and regulatory standards to highlighting practical examples of technology-driven maintenance. The discussions have emphasized that building and maintaining high-quality solar installations requires a comprehensive approach that spans the entire life cycle, from the initial build to ongoing operation. A huge thank you to all our speakers and panelists for contributing with their expertise and perspectives. Your insights are key to helping us push the solar industry forward. And also, of course, a big thank you to our audience for your engagement and participation. We look forward to seeing you at future sessions, where we will continue to explore critical challenges and innovations shaping the solar energy. Thank you, and have a great day.
This was Marian Willuhn, editor at PV Magazine. And now we're heading into our lunch break on this stage. But wait, we do have entertainment ready for you. Remember, you can check out our partners' booth and their insightful content there, and maybe even say hi to some of the representatives. I know they're waiting for you. So, my editorial colleagues are also looking forward to meeting you in our German or English networking sessions. I teased them before, but if you don't remember, have a look at the agenda and join the networking session right there. Apologies there. On this stage, we're back at 2 p.m. with Editor-in-Chief Michael Fuß for Session 5, Negative Electricity Prices, a Showstopper for Utility-Scale Solar. Michael has invited a broad portfolio of experts from Aurora Energy Research, Nuveen Infrastructure, Resource Platform, and Axpo. So, see you here at 2 p.m.